Good morning, everybody. My name is Josh Mack, and today I'm going to be going over with you a course project we have for our week 5 assignment, which is a community investigation and presentation. So before I get into the presentation itself, I actually wanted to give you a little bit of background on it, so that way you know what I'm talking about. So the scenario is as follows: in the last few weeks, residents have noticed an increasingly large number of dead fish washed up on the beach. The area is routinely used for a variety of recreational activities, including swimming, surfing, boating, and fishing. The local community is concerned about potential toxins in the water, especially since this would affect their health and local tourism industry. And in the effort to investigate this further, you have been hired to research this issue and present your findings to the next city council meeting. Specifically, council members have asked you to identify the toxins/hazardous chemicals present in the water. Once you've identified the responsible agent, they would like to know what specific impact this has on aquatic organisms and why the fish have died. They also want to know how their own health could be impacted. You will be preparing several written materials along with presentations that you will deliver to the community. So going into this assignment, I had to think about how I would present this to a city council. There were two trains of thoughts I had. One was that I could just go the complete and total biology route, using all of the big words that came along with it, and a whole bunch of other stuff. But from my perspective, how I saw it was I wanted to make something simple that was easy to understand for maybe people who don't have a degree in biology itself. Maybe they have the basic understandings and stuff like that, but they don't know everything that there is to know. And so what I tried to do is I tried to make it as simple as I could, but still get that information across that needed to be done. And what I actually chose was manure, and in particular fertilizer as well. So I used to live in Vermont for a long time, and this was actually something that did happen. Is we had a lot of crop fields up there, and we had a lot of pastures, and we used manure, we used fertilizer for these crop fields. And there were issues that did crop up in Vermont over the course of me living there, where we would have issues of body of water where you would find fish dead, and the one of the perpetrators of that was quite simply um, fertilizer that had gotten washed down from rainfall or overflooding or manure. And so this is what my presentation is about. So let's start with that. So manure and fertilizer and its ecological impact. So what I did was I went with two impacts. I went with the positive impact that manure and fertilizer can have on crops, and then I also did a negative impact. So the first positive impact we had was soil. Manure and fertilizer both have roles that can be played within soils. Manure increases water retention within the soils themselves, and fertilizer can easily be transported and quickly provide plants and crops needed nutrients. So this first one is quite simple. Basically, what manure and fertilizer allow is for plants to essentially just grow stronger. The manure will increase water retention within the soil itself. So that means that the plants can soak up more water without you having to waste the water itself. And for fertilizer, it gives the nutrients that maybe the manure and even the soils don't have for these plants to grow healthy and strong. The next one is plant health. Manure and fertilizer both have beneficial properties to help with plant health. Manure increases the number of microbes within the soil. Fertilizer can bring nutrients that otherwise plants or crops could be lacking. They might not otherwise be able to get on their own in the soil alone, which is what I just stated earlier for both of these. Now, what I will say is that for the second point that I have, manure increases the number of microbes within the soil. That is actually going to be in the negatives as well, and I will go into that when we get to it. However, as I stated before, with the fertilizer, it gives those nutrients that maybe you can't get in that soil, that maybe the manure doesn't give to it. And one of the last positives I decided to go with was growth. So manure and fertilizer increase crop yield and growth. Manure can increase crop yields by up to 5% if regulated correctly, while balancing the levels of nitrate. And fertilizer can ensure crops grow healthy and strong, helping to ensure blight and other diseases do not wipe crop yields. So what this is basically going on with is that with manure, it is kind of like a natural fertilizer. Some people like to refer to it as, but it can also be its own separate thing because manure doesn't have all of the chemicals that a fertilizer has. But basically, manure is the natural version of that, and so it can actually help increase a yield that crops would give. And for fertilizer, again, it gives those nutrients that maybe you wouldn't be able to get naturally in your soil, that maybe you don't have in your soil. And it basically helps to boost, like, what would root equivalency count for us as an immune system. So now we're going to go with the negative impact on this. So the first one is oxygen. When manure and fertilizer enter bodies of water, they can increase the production of microorganisms. When microorganisms production is increased, they can reduce the levels of dissolved oxygen in water. And when there's reduced levels of dissolved oxygen, it can cause plant life and fish to suffocate. So basically what I found out in my studies of this, and I actually got this from a study from North Dakota State University, ironically enough, all this info is where I got it from, and I will show this to you afterwards because I do want you to see this as well, is that just as I had stated before with the manure increasing microbes in the soil, it also stated that while great for soil is actually bad for water, because basically what happens is because the microbes increase, they feed off of the oxygen within the water, and so that with lower levels of oxygen within the water, it actually causes issues. Plant life will not grow properly. Fish will actually suffocate in water because they don't have enough oxygen within it. Another one is plant and algae growth. When manure or fertilizer is introduced to bodies of water, it brings with it nutrients used to increase crop productivity. However, increased levels of nitrate and potassium in lakes, ponds, and such will increase algae growth and weed growth within the body of water, which further limits the amount of oxygen within the bodies of water. Dead fish within the bodies of water then are broken down by microorganisms, further limiting oxygen supplies. So this is what I was just saying before. So because it's kind of like a nasty cycle, right? So not only are these microorganisms increasing within the water because of the manure and fertilizer, but because of the increased nitrate and potassium that comes with some of this fertilizer and manure, but mostly from the fertilizer, algae and weeds tend to grow much quicker because you have a higher richness in the soil in the ground. But as you can see from the picture I decided to use, you can see how it kind of just blots out a side of the lake, right? Well, that's stopping the rest of that lake underneath that from getting the sun that maybe those plants do use photosynthesis for, which we have in my class gone over before. And again, when that happens, the oxygen is sucked up, right? There's less oxygen in the water. And then when these fish die because of the less oxygen, these microorganisms that have been feeding off of this fertilizer and manure now feed off of the fish, which then, of course, creates more microorganisms, which feed off even more of the oxygen. Ammonia levels and toxicity. Fish are highly sensitive to ammonia levels, where even small changes can lead to mass death of fish populations. Manure and fertilizer can contain large quantities of ammonia. High levels of ammonia in water make it difficult for the organisms to get rid of it. So basically what I found out was that one of the main factors and first signs that there might be an issue with this is ammonia levels. And that's because fish have such unique bodies that even small changes in ammonia levels within the water can either outright kill them or make them seriously ill. And that would actually be one of the first signs you'd want to look for something like this, which is I didn't know. I didn't know that fish were so sensitive to stuff like this. And so because of that, it was quite interesting to figure that out. And because we're talking about manure, and because we're talking about fertilizer, there can be large quantities of this that if you have a rainfall, if you have a flood, anything like that, or if they're near lakes, streams, ponds, if it washes down into it, you will get excessive amounts of this, which then, of course, leads into other issues with humans. The other big one was nitrate. So nitrates are not naturally absorbed by the soils, meaning in heavy rains or times of flooding, they can be washed into bodies of water, which I have seen before. When in small doses, nitrite is not harmful. However, when looked at in commercial use with crops, it becomes deadly to fish and humans. Such issues will be seen within the circulatory system. Older and younger people are susceptible to lower levels. So these are the two big killers that you'll find with humans and fish in particular. The ammonia is going to be the first indication because that's what will kill the fish first. And then with nitrate, this is where things become a little more serious because high concentrations of this will, in particular, like I've said in one of the points, it affects the older people and the younger people far more because their systems can't hang up to it. And then that's what I had for that. So let's just go over a little bit more info here. For this, this was the website I used, and this is where I got all the info, right? So it goes over, oxygen depletion, weed growth and algae blooms, ammonia toxicity, that was the big one, right? There was also fecal organisms, which I didn't really want to go into too much because it didn't really kind of fit too much into it. It does, but it didn't. And then it's got the nitrates, of course, and then, of course, odors and gases. And so this was kind of the site I had, and that was in my citations as you saw. And if you wanted to get more info, that is a great thing to look at because it gives you everything you need. So the next one I had was right here. So this is literally the ammonia levels that will start killing fish. It says anything above 0.0 parts per million should be considered dangerous, which was absolutely baffling to me. I didn't know it was just that little bit that needed to be that. And then, of course, so this is another one. This is the facts about ammonia, and I will have this in my citations as well. It just kind of goes over like the effects of what ammonia can do, and in particular, how high concentrations of it can harm people. And so I'm hoping that by kind of making this simple, because I had to go and do it again, thinking, okay, well, I'm going to a city council meeting. How could this help? That was the presentation I decided to go with because it was simple. It was straightforward. It got the points across, and as well, I will have these links in case these people wanted to look more into it. So I hope with this presentation that you got the information you wanted, and I hope you have a wonderful day. Have a great day. Bye.